Try our hand at graphing inverses of functions graphically. And we know that when we got inverse functions, we just exchange the x and y coordinates. So here I've got a linear function, and I'm gonna talk about doing this a couple of ways. But one, we're just gonna do it by we're exchanging about 2 or 3 points on the x and y of the x and y coordinates, and then just graph it. So if I look right here, there I've got an ordered pair when x is 0, y is 3. So if I just flip those coordinates, I could say that when x, the inverse of that is when x is 3, 1, 2, 3, y is 0. All right, I got another one here that's on the grid line right here, where that when x is -1, y is 1. And again, I just switch that around to where when x is 1, y is -1. Let's put this coordinate right there. And I could actually just go ahead and graph it with those 2 points, but I see another one here on the grid line. We're going to plug that in to where when x is -2, y is -1. And when we reverse that, we would say that when x is -1, y is -2, which would put us an inverse right at that location. All right, then all I got to do is connect the dots, extend the line out, and shazam, we have graphed the inverse of that function. Now, another thing that I could do is I could go ahead and write this equation in slope-intercept form. It'd be easy enough to do. Because I see a y-intercept right here at +3. Let me change colors on that. And then I've got a slope of, I've got a rise of 2, a run of 1, and so we got 2x plus 3 equals y. And that should be the equation of that line. And then if I were to find that algebraically, remember, I'm just going to swap the x and y coordinates. And we're going to solve for y, so we'd end up with x minus 3 equals 2y. And then we're going to divide everything by 2, and once we do, we would have 1/2 x minus 3/2 equals y, and then we would write that in inverse function notation, such that the inverse function of x is equal to 1/2 x minus 3/2. All right, let's go look at another one real quick. Example here, when I'm looking at this function, it looks like a square root function. One of the things that kind of compresses it, pushes it down towards the horizontal axis, is the scale in which this thing is drawn. If you look at it, every grid line is a 10, both on the x and the y axis. It goes out here as far as 80 on the positive side of the x-axis, and 80 goes up to 80 on the positive side of the y-axis. I don't see any values of the function that are negative, either negative x or negative y, which again would fit it being a square root function, because you can't take the square root of a negative number, right? And if I look real close and I have to guess, if it's a square root function, let's see the way this thing is scaled. Well, if x was 16, y would be 4. So that would be right about there. Let's say right about there. And even with this scale, yeah, it looks pretty close. And if x was 25, the square root of 25 is 5. Let's say right about there. And that looks pretty close to that. But I'm going to graph this on the TI-84 calculator, and then I'm going to show you a special feature as to how we can draw the inverse of a function. It's pretty cool, pretty neat thing to do. So let's move over to the calculator. All right, well, here we are on our calculator, and let me just peek at my window setting right quick. Let's see, if it is a square root function, I don't really need to go to -10. I'm just going to go -1 for the y minimum, and I'll leave that at 10. I'm not going to make a big long one like the one we saw, and then -1 here for y minimum. All right, let's go in here and let's just graph a square root function. So y is then equal to the square root of x. Let's take a look at what this thing looks like. Okay, it's got that same shape. It's not as compressed, not as pushed down to the x-axis as the other one because it's got a different scale. And then if I go in here and look at the table, I can see that if I'm looking for perfect squares, see if x is 4, y is 2. If x is 9, y is 3. Square root of 9 is 3. If x is 16, square root is 4. I'm pretty convinced that this is a square root function. And now we're going to do the inverse. So I need to go to the draw section feature. And to do that, I hit second program. And then if I look down here at option 8, it says draw inverse. And so we're going to choose option 8. Brings me here to the math screen. And then we're going to vars. And we're going to yvars. And we're going to choose a function. And we're going to choose y1, which is where we graph that original function, and hit enter. And I think if we hit enter again, Shazam, there we go. It's graphing the inverse of that function. So let's see, let's go when x is 4, no, when x is 2, y is 4, that looks good. When x is 3, y is 9. I don't think our table will show us anything. Let me just go look and see, because we just drew it. No, it's not going to show us anything. But we can visually see it, and so that is the inverse. We have now drawn the inverse of that square root function. It's pretty interesting. Second program, choose draw, option 8, draw inverse, go to vars, then choose yvars, then choose function y1, which is where we originally graphed it, hit enter, and it'll actually draw the inverse function for us. That's pretty cool.